So back on your circular motion worksheet, I asked you to do numbers 7 to 10. So just ignore the fact that I have number 6 here, because it was really 7. Number 7, the Earth revolves around the Sun in a nearly circular orbit. Its average distance from the Sun, so it's telling us the radius, is 1.5 times 10 to the 8th kilometers, so it'll be 10 to the 11th meters. Find the orbital speed of the Earth, and it tells us that it takes 365.25 days, and I gave you that because people think a year is 365 days. It's really 365.25. You have to change this to seconds, and it becomes 31557600 seconds, and this is 1.5 times 10 to the 11th meters. And it's looking for speed, so it's just v is equal to 2 pi r over t. So 2 pi times 1.5 times 10 to the 11th meters over 31557600 seconds. And that is equal to times 2 times pi times 1.5 to the 11. You should get, that's a big number, 2.98653 times 10 to the 4th meters per second. There's a few more decimals. I promise I'll leave them in my calculator. Okay, that was part A. Part B then says, what is the magnitude of the centripetal acceleration? So AC is equal to V squared over R. So that 98653 times 10 to the 4th meters per second squared over the 1.5 times 10 to the 11th meters. So squared divided by 1.5 to the 11th. And you should get, this time tiny, 0.005946 meters per second squared, or 5.946 times 10 to the negative 3 meters per second squared. Okay, it's our AC. All right, and then part C, what is the size of the centripetal force of the Earth? So we know centripetal force is equal to mv squared over r. It's also equal to mac, and since I just found my AC, so it's equal to m 5.98 times 10 to the 24th, which I gave you in the question, times the centripetal acceleration you just found, for 6 to the negative 3 meters per second squared, and you should get an FC to be 3.55585, etc. So 3.55586 times 10 to the 22 newtons. That's a fairly significant force. Number 8. A merry-go-round makes 24 revolutions in 3 minutes. Remember, period from grade 11 is equal to the amount of time over the number of revolutions that go by. So 3 minutes is 180 seconds, and it says it makes 24 revolutions. So the period of this ride is 7.5 seconds. Okay, find the speed of a person standing 4 meters from the center axis. So V is equal to 2 pi r over t. So 2 pi times 4 meters divided by 7.5 seconds. V is equal to 3.35? 51 meters per second. That's part A. Part B is, how about a person who's standing 6 meters away? So everything is the same, except it's 2 pi times 6 meters over 7.5 seconds. So the speed now becomes 5.03 meters per second. So the further the way you are from the center, the faster you have to go. And sometimes people have a hard time with that, but that should make sense. Because if you're here, then your circumference is just this. right? But if someone's out here a distance 6 meters away, they have to go all the way around and get back to the same spot at the same time you do, so they're going to have to go faster. All right, flip to page. Number 9 says, a stock car travels around a curve that has a radius of 50 meters. So R is 50 meters. What angle must the curve be banked at if the car is to go around at 100 kilometers per hour? So V is 100 kilometers per hour. And it says assume frictionless. So that means you're like perfectly banking it for this speed. And this is 27.7 repeating meters per second. Okay, so when we do our curve, here it is. Here's my car. Okay, FG is acting down. This will be oh, don't do that. Ignore that. Let me flip. I was doing an inclined plane, and you don't want to do that. So let's try that again. FG is acting down. That is very true. But you don't change this. FN is acting up at an angle. And it has two components, FNY and FNX. And it's FNX that's going to be supplying the centripetal force. Okay, so you do sum of the forces in the y direction equal to MAY, and that'll be 0. So it'll be FNY minus FG equals 0. So FNY is really cosine theta is equal to mg. So Fn is equal to mg over cos theta. Then you go to sum of the forces in the x direction, which is equal to mv squared over r. And so Fnx is the only one since it's frictionless. And Fnx is really Fn sine theta equal to mv squared over r. Where your Fn is, fill this in. So mg sine theta over cos theta is equal to mv squared over r. The m's are going to cancel. This becomes g tan theta is equal to v squared over r, and you're solving for theta. So tan theta is going to equal v squared over gr. So tan theta is going to equal 27.7 repeating meters per second squared over 9.81 meters per second squared times 50 meters. Okay? Do not forget to square your speed. Divide by. So before you take the inverse tan, you should get 1.573. Then do second function tan, and you should get an angle of 57.556 degrees. This is a huge angle for like a regular car, but for a stock car, it's okay. It's not too big. They're banked much more. All right, now it's time to get to the fun one, which is adding friction. All right, so number 10. I can't remember which way I did it in class, so I'll do it this way, and we'll see which one screws you up. Okay, so here's my car. Here's my FG. I think this was the one I did, the way I did it in class today. Fn, Fny, Fnx. All right, so 10 says a curve of radius 70 meters is perfectly banked for a car traveling 60 kilometers per hour. Perfectly banked, that means there's no friction, and it means that we can find the angle using that 60 kilometers per hour. And 60 kilometers per hour is 16.6 repeating meters per second. What must be the coefficient of friction when it wants to go around at 90 kilometers per hour, which will be 25 meters per second. So we'll come back to this second part. Actually, I guess we're going to come back to both because the video is going to end. So we'll come back and do this one in a separate video in a second.